Lesson 8-1, we're going to be talking about line plots. So display and analyze data using a line plot. Statistics can be used basically any any type of data that we can collect, whether that be a basketball game, a football game, a volleyball game, or at a grocery store, they can keep track of how many people buy a certain type of product. The data is what we collect. How many shots are made. A line plot is what we're going to be using today to display the data. There's a lot of different ways we can display data. We can use bar graphs, we can use histograms, we can use stem and leaf plots. Today we're going to be talking about a line plot. And a line plot is where you have a line with some numbers down here, so like 15, 16, 17, 18, and then whenever you have a piece of data, you put an X. So if we have a 16, then if we have an 18, then if we have another 16, then we have a 15. And so this is what a line plot looks like. A cluster is data that is grouped closely together. So in my example right here, we could consider that 15 and 16 make a cluster because there aren't any gaps at all. Outlier. An outlier is data that's separated from the rest of the data. So let's say, for example, if I continue this out, and let's skip a few here, and if I said, 28, 29, and all of a sudden I had one way out here at 29, okay, I could say that 29 is an outlier because it's data that's separated from the rest of the data. Now, if there's other data out there, I wouldn't call it an outlier, but if it's all by itself, then yeah, I could go ahead and call that an outlier. A gap. Gaps are when we have gaps in the data. So right now, 17 could be a gap because there's no data there, but we have data to the left and to the right of it. So 17 could be a gap. This part right here would be a pretty big gap. How do you find the range when using data? You take your maximum and subtract your minimum. Okay, so right now 29, you'd say 29 minus our lowest number is 15, and the range is 14 for this piece of data. So that means that our data is spread out over 14 different numbers, and that's what the range represents. Analyze, that's what we like to do with statistics, is once we get data, then we like to analyze, interpret what it means. So going on here, the first one, we're going to actually have to do a little bit of graphing. The table below shows the ages of U.S. presidents at the time of their inaugurations. Make a line plot of the data. So what you do is you just go ahead and figure out a method to use to do this in an orderly fashion. So here's 57. Okay, I'm going to cross it off, and I'm going to go ahead and put an X on 57. Okay, there's 61. I'll cross that one off, put an X on 61, and so on. I'll continue this until we're finished. Okay, so I went ahead and filled out the rest of the table and the graph. So you see I've crossed off every number, and every number is represented by an X down on the number line. Now you can start to see some patterns, and you can see where some of the things are. So now the directions say identify any clusters. So let's go ahead and fill out our clusters. All right, looks like a cluster here from 46 through 52. Then we have another cluster at 54 through 56, 7, 8. All right, and then we have some small clusters here. We could say 60 to 62. And if you wanted, you could say 64 and 65. So those are some clusters where we have a bunch of data kind of grouped together. All right, so where are the gaps? Well, if those are our clusters, pretty much all the spaces in between are gaps. So we have 44 and 45, the gap. Right here, it looks like we have a gap right there, but it's just a one number gap, so I guess I wouldn't necessarily call it much of a gap. Over here we have 66 to 67 is a gap right in there, okay? So again, I won't necessarily call this a gap because it's just one number missing. I usually like it to be a little bit bigger than that. All right, any outliers? Um, we could consider maybe these two both being outliers and possibly these two being outliers. Um, they're not really that far away from the rest of the data, so I don't know if I would actually consider them to be outliers, but if you wanted to, we can include that. We could say 42, 43, and then we could say 68 and 69. If you do say one of them, make sure you say both of them because they're right next to each other and there is a gap. We actually call both of these gaps. So again, it's okay to sometimes say none. If you don't really have an outlier, you could just say none. So maybe in parentheses right here we'll include none. But if you were to consider any outliers, those would be it. So now it says to find the range. So I'm going to write the range over here. Okay, and so the range is the maximum, which is 69, minus the minimum, which is 42. And so the range is 27. Okay, and that's the answer. The answer would be 27. You don't say the range is 69 minus 42. You say the range is 27. Range is just one number. And that one number represents that we have inaugurated presidents over 27 different ages, all the way from 42 and all the way as old as 69. So there's 27 years of difference between the youngest president ever and the oldest. All right, so the line plot shows the number of inches of precipitation that fell in several cities west of the Mississippi River during a recent year. Identify any clusters, gaps, and outliers. So here, the data is already here for us. So let's go ahead and list some clusters. All right, so looking at some clusters here, I have a span of 3. I could say 11 to 13. And 16 to 18. And that's about all. I'm not going to just say 2. Twos aren't enough for me to call it a cluster. So let's go ahead and say gaps. Okay, any gaps that I have in here? Well, this is a 3 gap. We could say 6, 6 to 8, 6, 7, and 8. This is just a 2. Oh, this is a pretty nice gap here. We have 19 to 22. This is another pretty big one. We have 28 through 31. This is just a 2. This is a 2, a 2. We do have 3 here, so we could say 47 to 49. So those would be things that I would consider as gaps. You know, you could call every single space a gap, but that gets a little bit redundant. All right, now outliers. You could call 5 an outlier, and it's all by itself, and you could call 50 an outlier. So we have 5 and 50 as outliers. We did call both of these gaps, which is important. If we wouldn't have called these gaps, then I probably wouldn't call them outliers either. And then the range is actually going to be our maximum, which is 50, minus our minimum, which is 5, and so we have a range of 45, and that's our answer for the range. Keep in mind, this is not the range. 50 minus 5 is not the range. The answer, 45, that is the range. And what that means is there's a difference of 45 inches of precipitation between the lowest and the highest. So, you know, that means it's pretty spread out, really. And then looking at all the gaps, we have quite a few gaps in there. So it kind of helps us understand why it's so spread out. So describe how the range would change if an additional data value of 50 was added to the data. So if we look back here, we only have one 50. Now the data is the exact same except for now we have two 50s. Does that do anything to the range? Well, think about range. Range is maximum minus minimum. Is adding another 50 going to do anything, or are we still going to have 50 minus 5, which equals 45? Adding another maximum, as long as it's the same number, does nothing to the range. Now, if they would have added like a 51, or if they would have added a 4, then it would have changed the range. If they add anything that we already had, or they don't change our maximum or minimum number, our range is unaffected. For example, 4, the line plot below shows the ages of students in an introductory computer course at a local community college. Identify clusters, gaps, and outliers of the data, then identify the range. So let's do the clusters first. Let's see, I have a group of 2 here. So really, you know, if you think about what I said before, I was looking for groups of 3. So I mean, you could call this one group of 2 here a cluster, but I mean, the 20 only has 1. So you know what? I'm actually going to say there's none. There's no clusters. So if we don't have any clusters, then we should probably have some gaps. This is just a 1, a 1, a 1, a 1. We do have a 2 here. We could list that one if we felt like it. We could say 28 to 29. And then this is a pretty big gap here, so we're going to list that one. We have a 31 to a 43. So we have a pretty nice span gap right there. Thinking about our clusters again, you know, because we couldn't really find much for gaps. If you wanted to, you could think of this whole thing as a cluster. Maybe not include this because there is a 2 space there. So you could maybe say 18 all the way to 27. And that whole thing could be a cluster for you. So, you know, you may want to include that since there are only ones and you're not going to call them gaps. Now, this is a gap, so we will include this in our cluster. Now, outliers. This one is really obvious. We haven't had one like this before. So 44 is definitely an outlier. You do not need to have a low and a high outlier. In this case, this is definitely not an outlier. We actually considered that possibly being in our cluster. So 44 is definitely our only outlier here. And then our range. Well, we have 44 as a maximum, and our minimum is 18. Now, it doesn't matter that we have 3 18s. 18 is still our minimum number. So when we do this, we'll take 44 minus 18, okay, and so that'll be a 14, that'll be a 30, and we'll say 6 and 2, so 26 is the range. So that means the age range for the students in the intro computer course ranges about 26 years from the youngest to the oldest student. Okay, so words typed per minute. We want to do clusters first. All right, so cluster here definitely from 25 to 50. Notice here though that we have a span of 5. So these are going up by 5s instead of 1s. So, you know, we could maybe stop the cluster at about 45 because you see there's only one piece of data out there. But I'll go ahead and include it anyways. We can go ahead and say 25 to 50 is a cluster because looking at our graph, this is definitely a cluster of data. Okay, what kind of gaps do we have? Well, we really only have one, and that'd be from, you could say, from 11 to 24. I am including 11 because it would be right here, and 24 would be right here. So I'm not just going to say 15 to 20. I'm going to go ahead and say 11 to 24 would be a gap. Then outliers would be this 10. Now we don't have a maximum outlier up here, so 10 would be our only outlier. And then our range. The range is going to be from 50 we're going to say 50, oops, sorry about that. For a range, we're going to say 50 minus 10, which is 40. So there's a range from our fastest person of 50 to our slowest person of 10 words per minute. There's a range of 40 words per minute in our data. Now it says what percent of people type faster than 35 words per minute. So we want faster than. We do not want to include these here. So we just want to talk about this. All right, and we're talking about percent. So we have 1, 2, 3, 4, 5, 6. We have 6 people that are typing faster than 35 words per minute out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. There's 14 people slower plus the 6, so there's 20 people altogether. Okay, and we know that since we want it to be a percent, it's got to be over 100. All right, and so 20 times 5 is 100, so multiply the 6 times 5 and we get 30%. Okay, that's one way to do that, or you could have just taken 6 divided by 20 and then multiplied by 100, and that would also get you 30%. So 30% of the people in this class type faster than 35 words per minute. Okay, so for our last one, I'm going to go ahead and let you do this one. You're going to need to make a number line. What you do is you find the minimum number and make that your lowest number, and then you find your maximum number and make that your maximum, and then you even out the rest of your line. So you figure out what you want to go by. You're going to go by ones, you're going to go by fives, what's the number you're going to go by. Then you're going to put your X's on all your points and figure out clusters, gaps, outliers, and range. Okay, so for today's homework, if you need some extra help, you can watch the online tutorial on Moodle or check out the step-by-step homework helper for all the odd problems.